Hello everyone. This video will review for test 4. There are 27 multiple choice questions in test 4. Number 1, LCM of 10 and 30. This is a special case number 1. When you have two quantities, one is a factor of the other. You can see in number 1, 10 is a factor of 30. 30 is a multiple of 10. In this case, LCM is the multiple, is the bigger number, because 30 is a triple of 10. 30 is one time of 30. So 30 is a common multiple of both. Since 30 is the smallest multiple of 30, 30 is the smallest common multiple. Since 30 is the smallest multiple of 30, 30 is the smallest common multiple of the two numbers. Yeah. Knowing LCM here represents the least common multiple. Number 2, look for LCM of x and x cubed. We know x cubed is x times x times x, right? So x, the blue quantity is a factor of the green. Do you see that is special case number 1? In special case number 1, the LCM would be the one has bigger exponents. Okay, x cubed is a multiple of x. X cubed is a multiple of itself. That makes x cubed a common multiple of both. Since x cubed is the smallest multiple of itself, x cubed is the smallest common multiple of the two quantities. Special case number 1. Special case number 1, the two quantities, one is a factor of the other. Number 3, finding LCM of the blue expression and the green expression. When you look at the two expressions, you should see the blue is a square of the green. The green is a factor of the blue. X minus 1 to the power of 2 is x minus 1 times x minus 1. So x minus 1 is a factor of the square of x minus 1, right? So the LCM would be x minus 1 to the power of 2. Special case number 1 again. Number 4. LCM of 4 and 7. If we prime factor 4, we have 2 times 2. If we prime factor 7, we have 7 equals 7. You can see the two numbers have no common factor except 1. So the two numbers are mutually prime. That's our special case number 2, mutually prime. If the two numbers are mutually prime, GCF is 1. LCM is their product. 4 times 7, 28. Number 5, the same thing. A and B are mutually prime. So GCF is 1. LCM is their product, A times B. Number 6, blue binomial, green binomial. They are mutually prime, obviously, right? They do not have any common factor except 1. Because x plus 2 itself is a prime binomial. X plus 4 is a prime binomial. The two polynomials have nothing in common except factor 1. Since they are mutually prime, GCF is 1, LCM is their product. X plus 2 times x plus 4. So your result, your answer would be the multiplication of the two binomials. Number 7, we need to look for the LCM of 30 and 36. I'm going to show you the solution for this problem here. When you look at the 30 and the 36, it's not a special case number 1 because 30 is not a factor of 36. It's not a special case number 2 either because besides 1, the two numbers obviously has common factor 2 and a common factor 3, right? So this is not a special case. For a problem like this, we have a 3-step procedure. Step 1, we are going to prime factor both numbers. We use the technique we have learned from the beginning of the semester. We place 30 on the big L. 30 is even, divisible by 2. So divided 30 by 2, we have 15. 15 is divisible by 3. You can use your calculator to assist you. 15 divided by 3, we have 5. 5 is a prime, so we complete the diagram. We can interpret the diagram here as 30 equals 2 times 3 times 5. We're going to do the same thing for 36. Place 36 on the big L. 36 is even, divisible by 2, so we have 18 here. 18 is even, another 2 as factor. Divide 18 by 2, we have 9. 9 is divisible by 3. Divide 9 by 3, we have 3. 3 is a prime, so we stop here. Therefore, the factorization of 36 is 2 times 2 times 3 times 3. That's the first step, prime factor both numbers. Step 2, bubble. I use color red to bubble the common factor and use green to bubble the leftover factors. Step 3, I'm going to multiply all the factors in the bubbles. But when it comes to common factor, we only copy it once. You can see we have 2 2's in the first bubble in red. We have 2 3's in the second bubble in red, but we only write them once. We copy 2 once, copy 3 once. Copy 5, 2, and 3. The other 3 factors. And we multiply them all together. We have 180. Use your calculator. 2 times 3 is 6. 6 times 3 is 18. 18 times 10. 5 times 2 is 10. Is 180. So the LCM of the two numbers is 180. Number 8. Find all the numbers not in the domain of the function. Let's look at the number 8. The function is a quotient of numerator, denominator. The denominator is 7. It's not equal to 0. So this function is well defined for any real numbers x. No matter what x equal to, the function is well defined because the denominator is non-zero. It is a constant 7. So the answer will be none. No number will be excluded from the variable x. Number 9. Function number 9 has numerator 7, denominator x plus 5. Denominator cannot be 0. The denominator of this function is x plus 5, so x5 cannot be 0. Now we are looking at an inequality. We are going to solve this inequality. Minus 5 from both sides. Cancel 5 and negative 5. We have x not equal to negative 5. Negative 5 will make the denominator be 0. So negative 5 would be the excluded value for the function, or the number not in the domain. So for number 9, the number you're going to choose is a -5. A trick for this type of problem is that if the denominator is x plus a number, the number is in red, then the answer would be the opposite of the number. For this problem, the denominator is x plus 5. Plus 5 is in red, right? So the answer is the opposite of 5, which is a -5. Because if you plug in -5, you will have the denominator 0, and that is not defined. That is not well defined. Number 10, same requirement. Let me copy the function in number 10. F of x equals x squared minus 64 all over x squared plus 4x minus 12. What's the denominator? The denominator of the function is x squared plus 4x minus 12. It cannot be 0. It cannot be 0. On the left of the inequality, we have a quadratic trinomial with leading coefficient 1. We are going to use the shortcut method. We are going to use the shortcut method to factor the quadratic trinomial with leading coefficient 1. We need to look for two numbers. Their multiplication is -12. Their sum is +4. By the shortcut method, we have learned the two numbers are going to be +6, -2, right? +6, -2 multiplied to -12, add up to +4. Look at the two numbers in red. What are their opposite? Their opposite would be -6 and +2, right? Those two numbers are the excluded value because -6 would make the first factor be 0. If you plug in x equals -6 in the first parenthesis, you will have 0, and that would make the denominator be 0. 2 will make the second parenthesis be 0. So x cannot be 2. X cannot be 2. Simply just take the opposites of the two numbers. Those two numbers will be the excluded value. Okay. Number 11, find all numbers that are not in the domain of the function, then give the domain using set notation. F of x is a rational function. The denominator is 2x. Denominator cannot be 0, right? Solve this inequality. Divide both sides by 2. We would have x not equal to 0. 0 over 2 is 0. So 0 is the excluded value. The domain of the function would be any real numbers except 0. So you're going to look for something like that in the answer choices. 0 column follow with a set. The set contains all the real numbers except 0. Number 12, simplify the rational expression. Number 12 is pretty special. Numerator is 3 minus x. Denominator is x minus 3. We can do a practice here. If you have 3 and 7, 3 minus 7 is -4. 7 minus 3 is a +4. The two numbers are opposite, right? If you put one on the top, the other on the bottom, you will have -1. Means what? Yeah, I'm trying to show you the pattern. Means the quotient of two numbers which are opposites of each other is a -1. We can try other cases. 10 minus 5, +5. 5 minus 10, if you switch the order of the two numbers in the subtraction, 5 minus 10, -5. If you put one on the top, the other on the bottom, quotient is -1, right? Again, you see the pattern. The quotient of two numbers, the two numbers are opposites of each other. Quotient of them is a -1. 3 minus x, x minus 3, they are opposites. So the quotient of them would be -1. So the reduced form of the given expression is -1 because the numerator and the denominator are opposites. Number 13, express the rational expression in the lowest terms. So number 13 is also to reduce or simplify the given rational expression. Good news is in number 13, both the numerator and the denominator are factored. You don't have to factor it. The numerator has two factors, y plus 7. You need to know y plus 7 is one factor inside the parentheses. Another factor, y minus 6, that's the numerator. Denominator has two factors as well, y minus 6 times y plus 8. Look at the numerator and the denominator. We see those two factors are the same, right? So they can cancel each other. They will become 1 in the top and the bottom. Then the rational expression will be reduced as y plus 7 over y plus 8. Y minus 6 is cancelled, but y plus 7 is still there. On the bottom, y plus 8 is still there. So the final result is this expression. Number 14, perform the indicated operation and express in lowest terms. Number 14, we need to multiply the two rational expressions. So number 14, multiply the two rational expressions. Let me copy the expression and we're gonna deal with the multiplication here. 5x squared, 2x minus 2. So we are multiplying the two rational expressions. First step, factor all the numerators, all the denominators. 3x minus 3 is 3x minus 3 times 1. This binomial can be factored as 3 times x minus 1. They both have a common factor 3, so you can factor out 3. If you are not sure, you can distribute. 3 times x, 3x. 3 times -1, -3. So the numerator of the first rational expression is 3 times parentheses. Inside the parentheses, you have x minus 1. Denominator is x. Is already factored. Multiply by second rational expression. Numerator 5x squared. We know x squared is x times x, right? So we can write the numerator as 5 times x times x. Denominator is 2x minus 2. 2x minus 2 is 2x minus 2 times 1. Both of the two terms have a common factor 2. So you can factor it out. You factor it out inside the parentheses, you will have x minus 1. If you distribute, you will have the original binomial, 2 times x, 2x, 2 times -1, -2. So the factored form of the denominator will be 2 times x minus 1. Okay, after all of those, we finally ready to multiply the two rational expressions. And we do have to make effort to factor everything. Let's see how do we multiply the two rational expressions. Remember, how do we multiply two fractions? We do vertical, vertical, diagonal, diagonal to cancel all the common factors, and then we multiply cross to get the final result. In this case, vertical, we have nothing. Vertical, we have nothing. But diagonally, look at these two. X, X. They cancel each other, right? The other diagonal, x minus 1, x minus 1, cancel each other. They all become 1. Left over, the first rational expression becomes 3 over 1 right now because x minus 1 is cancelled, x is cancelled. Second rational expression, numerator, we still have 5 and x, so 5x. Denominator, we have 2. And we multiply across. 3 times 5x, 15x. 1 times 2, 2. So the reduced form of the product would be 15x over 2. Number 15, multiply two rational expressions. Both of the two rational expressions are factored already. The first one, x minus 2 times x plus 5. The first rational expression has a numerator as a product. It has two factors inside the parentheses. Denominator has two factors, x plus 8, x minus 2. Second rational expression, numerator is factored, x minus 10, factor 1, x plus 8, factor 2. Denominator factored, x plus 5, factor 1, x plus 6, factor 2. And we can see we could cancel some common factors from the top and the bottom. We can see x minus 2 could be cancelled, right? That's vertical. Vertical, the second vertical, we have nothing to cancel. Diagonally, x plus 5, and x plus 8, right? So all those factors are cancelled. They become 1. The leftover factor, we still have a leftover factor here and here. So the reduced form of the multiplication would be x minus 10 all over x plus 6. Number 16, divide two fractions. Very straightforward. Divide 3 over 7 by 4 over 5. Firstly, we apply keep change flip to write a division as a multiplication. Keep the first fraction, change the division to multiplication, flip the second fraction. And then we do vertical, vertical, diagonal, diagonal. If there's nothing to simplify, we would multiply cross. 3 times 5, 15. 7 times 4, 28. Final result, 15 over 28. Number 17, multiply two fractions. 1 over 3 times 2 over 5. Vertical, vertical, diagonal, diagonal, nothing to be cancelled. So multiply cross. 1 times 2, 3 times 5. That's the final result. Number 18, add two fractions with the same base, with the same denominator, or the same bottom. 1 over 8 plus 3 over 8. We keep the bottom, solve the top. 1 plus 3 is 4. 4 over 8. Reduce 4 over 8. Divide 4 by 4. We have 1. Divide 8 by 4. We have 2. So the reduced form of the addition is 1 over 2. Number 19. Multiply, adding two fractions without the same denominator. So I'm going to write number 19 here. Number 19, 1 over 5 plus 2 over 3. 1 over 5 plus 2 over 3. They do not have the same denominator. So we have to find their least common denominator. Their least common denominator is the least common multiple of the two denominators. 3 and 5 are mutually prime. So this is the special case number 2. Special case number 2, mutually prime. If the two quantities are mutually prime, the LCM of them is their product, 15. So the least common denominator of the two fractions gonna be 15. So we are going to go ahead to change or rewrite both fractions as their equivalent fractions with denominator 15. In order to do so, the first fraction, we need to multiply both top and the bottom by 3. Then the denominator would be 15, right? That is 3 over 15. For the second fraction, we multiply both top and the bottom by 5 to make the denominator as 15. And that is 10 over 15. Now they have the same denominator. We keep the denominator, solve the top. That is 13 over 15. 13 over 15 is already reduced. So that would be the final result. Number 20. Number 20, we are looking for the addition of 1 over 14 and 1 over 7. Number 20, 1 over 14 plus 1 over 7. These two fractions have no common denominator either. So we need to make them have the same denominators. We need to find their least common denominator. Least common denominator is the least common multiple of the two denominators. You can see 7 is a factor of 14. 14 is twice of 7, right? 7 is half of 14. 14 is twice of 7. That is the special case number 1. Special case number 1. In the special case number 1, you know the bigger number is going to be the LCM. So we're going to write both fractions as their equivalent fraction with denominator 14. The first fraction has already denominator equals 14. So we just copy it. The second one, in order to make the second fraction has a denominator 14, we multiply both top and the bottom by 2. So we have a fraction which is 2 over 14. 2 over 14. Now they have the same denominator. We keep the denominator, solve the top. We have a 3 over 14. 3 over 14. Number 21. Let me erase those, then we can have more space for number 21. Number 21, we are adding two rational expressions. Number 21, we are adding two rational expressions. One is 2 over 9x, the other is 8 over 9x. You can see the two rational expressions have the same bottom, right? If they have the same bottom, and you just keep the bottom and solve the top. 2 plus 8. You have 10 over 9x. Look at 10 and 9x. They do not have a common factor except 1. So that is reduced already. The final answer would be 10 over 9x. Number 22. We are adding 4 over x and 5 over 7x. The two rational expressions have no common factor. And we have to make them have the same denominators, right? I mean, so far, these two rational expressions have no common denominator. We have to find their least common denominator. The least common denominator is the least common multiple of x and 7x. X is a factor of 7x. 7x is 7 times x. So that's the special case number 1. LCM is the multiple, 7x. 7x is gonna be the least common denominator. We are going to change both rational expressions as their equivalent rational expressions with the denominator 7x. The second one is already there. The first one, we're going to multiply both top and the bottom by 7 times 7 times 7. Numerator would be 4 times 7 is 28. Denominator would be 7x. Yeah, the numerator 4 times 7, 28. Denominator x times 7, 7x. Now they have the same denominator. We keep the denominator, solve the top. 28 plus 5. 28 plus 5 is 33. 33 over 7x. That's the final answer for 22. 23. Let me copy 23 right here. Is 3 over x plus 9 over x minus 8. We are adding the two rational expressions. They do not have the same denominator, so we need to find their least common denominator. The least common denominator of the two rational expressions is their least common multiple of the two denominators, x and x minus 8. Knowing that x minus 8 is one factor, is one whole thing. And look at the two denominators, x and x minus 8. They are mutually prime. No, they are mutually prime. So this is a special case number 2, mutually prime. Least common multiple of two quantities that are mutually prime is their product, x times x minus 8. Remember that? So we're going to write both rational expressions as their equivalent rational expression with the denominator equals the least common denominator. Okay? In order to do that, the first rational expression, both top and the bottom, multiplied by x minus 8. The second rational expression, both top and the bottom, multiplied by x. So now they have the same denominators, right? We keep the denominator, solve the top. Yes, we need to simplify the numerator. Copy the denominator. Distribute 3 times x, 3x. 3 times 8, 24. Plus 9x. Combine like terms. 3x, 9x, 12x. Plus 24. All over x times x minus 8. In order to know if the numerator and the denominator have any common factor except 1. In other words, in order to know if we can simplify the result, we have to factor the numerator. Factor the numerator, we have 12 times x plus 2. Because 24 is 12 times 2. Denominator is x times x minus 8. So you can look at the numerator and the denominator. They do not have any common factor. So this will be the final result. The numerator is distributed. The numerator is expanded, not factored in the answer choices. Repeat the video. If you have any confusion, just repeat it. Try to make sense of each step. I believe you will get there. Number 24, dividing. Number 24, simplify complex fraction. Let me erase those to get more space for number 24. So number 24, we're simplifying the complex fraction x over 9 over 5 over x plus 8. This is a complex fraction. Numerator is one single rational expression. Denominator is one single rational expression. For that type of complex fraction, we use the first method. The first method is to convert the fraction bar here as division symbol. So this is the fraction bar, numerator, denominator. So the fraction bar here, this one, fraction bar here is a division symbol. So we are going to convert the fraction bar as the division symbol. So we have that expression as numerator divided by denominator. So after this step, the problem becomes, the complex fraction becomes the division of two rational expressions. How do we divide the two rational expressions? We keep, change, flip first. Keep, change, flip. Keep the first rational expression, change the division to multiplication, flip the second rational expression. And then we multiply. We look at the vertical, diagonal, nothing can be cancelled. So we multiply across. Numerator times numerator. Denominator times denominator. 9 times 5, 45. Numerator is x times x plus 8. That's number 24. Number 25. Simplify the rational expression is 2 plus 4 over x all over x over 6 plus 1 over 3. This complex fraction, this is a complex fraction. This complex fraction has two terms in the numerator, two terms in the denominator. So the method we applied earlier does not work in this case anymore. So we're gonna use the second method we learned from the class. We see those three small denominators. We're gonna go ahead to find the least common multiple of those three denominators. Is 6x. 6x is multiple of x, multiple of 6, multiple of 3, and the smallest common multiple of all the three. So that's the least common multiple. And then we are going to multiply each single term in the expression, in the complex fraction, by 6x. We multiply 2 by 6x plus 4 over x times 6x. That is 6x over 1. Denominator, x over 6 times 6x over 1 plus 1 over 3 times 6x over 1. The purpose for doing this is to eliminate all the denominators, to get rid of all the denominators. Let's see what will happen after this. We'll see that the first term in the numerator, 2 times 6x gives us 12x. The second term in the numerator, x and x cancel each other, right? They cancel each other. So the second term becomes 24. 4 times 6, 24. On the bottom, the first term, 6 and 6 cancel each other. So the leftover can turn x times x. That is x squared. The second term on the bottom, diagonally, you can see 3 and 6, they have a common factor, 3. So 3 will become 1, 6 will become 2. So the second term of the denominator gives us 2x, So as I said, we have to factor both top and bottom to see if we can further reduce the result. Numerator, 12x plus 24. Obviously, 24 is twice of 12. So we can factor 12 out. Inside the parentheses, we have x plus 2. Denominator, x squared plus 2x. The two terms have GCF x, so we factor x out. Inside the parentheses, we have x plus 2. So if you are not sure, there's a way you can double check is to distribute. 12 times x, 12x, 12 times 2, 24. X times x, x squared, x times 2, 2x, right? Yeah. And now look at the numerator and the denominator. They are the same, so they are cancelled. The result would be 12 over x. Number 26, solving equation. Let me copy the equation right here. Equation is 1 over 5x plus 1 over 3x equals negative 1 over 15. We're going to apply the 5-step procedure to solve this equation. This is a rational equation. In the class, we have learned we need 5 steps in order to solve this equation, right? We need 5 steps in order to solve this equation. Step 1, identify the excluded value. The excluded value here is 0. How do we know that? This denominator, 5x, cannot be 0. Divide by 5, we have x cannot be 0, right? And this denominator cannot be 0. Over 3, divide by 3, we have x not equal to 0. 15 is fine, 15 is non-zero anyway. So you can see, for this equation, there is one excluded value, which is 0. So you have to write that out. You put a comma here, and you write x not equal to 0 after that. To remind yourself, 0 is not in the domain. 0 is not in the domain. So that's the first step. Second step, you're going to look for the least common multiple of the 3 denominators. Okay? Find the least common multiple of the 3 denominators. 5x, 3x, 15. The least common multiple of the 3 is 15x. You have to have x. 3 and 5, both of them are factors of 15. So the LCM is 15x. LCM is 15x. That's step 2. Find the LCM for all the 3 denominators. Step 3, we're going to multiply all the terms in the equation by the LCM. So 1 over 5x, we multiply that by 15x over 1 plus 1 over 3x, multiply that by 15x over 1 equals negative 1 over 15 multiplied by 15x over 1. Purpose of doing this is to eliminate denominators, get rid of denominators. Let's see what will happen. Let's see this 5 and 15. 5 is cancelled. 15 will become 3, right? So you're going to have a 3 there. Yeah, knowing you're going to have a 3 there. And x and x cancelled. X cancel x. X cancel x. 5 becomes 1. 15 becomes 3. You need to be clear that the first term becomes 3. Everything else are cancelled. So the first term is 3 right now. Okay? Yeah, 15 over 5 is 3. X cancel x. So the first term is 3. Second term, x cancel x. And 15 over 3, that's 5. Numerator, you have 15. Denominator, you have 3. 15 divided by 3, that's 5, equals. On the right-hand side, you have a negative times a positive, that's negative. 15 cancel 15, right? And you have a negative x on the right-hand side. On the left, 3 plus 5, 8. 8 equals negative x. Or if we switch the sides, we have negative x equals 8. Multiply both sides, or divide both sides by negative 1. We have x equals negative 8. That's the step 4. Step 4, solve the equation for x. We got x equals negative 8. Step 5, very, very important. When we solve a rational equation, we need to check the result. We need to look at the proposed solution and the excluded value. We need to look at them to see if they have any, to see if there's any contradiction. To see if there's any contradiction. Negative 8 obviously is not a excluded value. If you don't see any contradiction, you will keep the proposed solution, and you can conclude the solution set of the equation is a set containing negative 8. Number 27. Let me copy number 27. The equation is 5 over x minus 3 plus 9 over x equals negative 27 over x squared minus 3x. Okay. This equation is a rational equation. It contains 3 rational expressions. The difference between this problem and the previous problem is the denominator. Denominators here is more complicated. In this case, the first step will be factor all the denominators and identify the excluded value. So let's do that. Copy 5. Denominator is x minus 3. X minus 3 is prime, so I put a parenthesis to frame it. Plus 9 over x equals negative 27 over denominator x squared minus 3x. We can factor that binomial as x times x minus 3, right? So the denominator would be x times x minus 3. From the factored form of the denominators, we are able to identify the excluded value. We have 2 excluded values. They are 0 and 3. X cannot be 0, x cannot be 3. Because we have a denominator x. We know denominator cannot be 0, right? So 0 is 1, is the first excluded value. How do we know 3 is also an excluded value? Because if we plug in x equals 3 here, 3 minus 3, the denominator will be 0, right? So we'll see the equation has 2 excluded values. That is 0 and 3, the first step. Step 2, Find the least common multiple of all the three denominators. They are x minus 3, x, and x times x minus 3. The least common multiple of the three expressions is x times x minus 3 because, let me explain. Because this expression is a multiple of this one, also a multiple of this one, because it's the product of those two, right? Also a multiple of this one. And make sure you see this would be the special case number 1. Special case number 1. Those two expressions are factors of this one. So the least common multiple by the special case number 1 is the product of them. Is the third one. Is this one. Okay? Step 2, find the LCM. Step 3, multiply each single term in the equation by the LCM to eliminate the denominator. So we have 5 over x minus 3 multiplied by x times x minus 3 over 1 plus 9 over x times x minus 3 over 1 equals negative 27 over x times x minus 3 times x times x minus 3 over 1. To get rid of the denominator, let's see, how do we get rid of the denominator? Diagonally, x minus 3 cancel x minus 3, right? So the first term becomes 5x. Know that you have 5 and x on the top, plus second term, x cancel x, they are gone, they become 1. So the leftover becomes 9 times x minus 3. On the right hand side, x times x plus 3, x times x plus 3, they are all cancelled, right? So that is a negative 27. Let's solve this equation. Step 3, multiply each single term by the LCM to get rid of the denominators. Now you have an equation without any denominators. So we can solve the equation for x. That's step 4. Distribute 9 times x, 9x. 9 times negative 3, negative 27 equals negative 27. Yeah, we notice we have negative 27 on both sides. So if we plus 27 on both sides, it will be cancelled. Then we will have 5x plus 9x equals 0. 5x plus 9x is 14x equals 0. Divide both sides by 14. Yeah, this is actually simple, but people turns out make a mistake in this case, in this step. Left hand side 14 over 14, 1. 1 times x equals right hand side. Use your calculator. 0 divided by 14 is 0. So your proposed solution is x equals 0. Step 5, very, very critical. When you solve a rational equation, you need to check your result. You need to look at your proposed solution and your excluded value. Do you see any contradiction? In the beginning, we identify 0 and 3 are excluded, means 0 and 3 not even in the domain. 0 and 3 will not make the equation well defined. However, in step 4, we got a proposed solution equals 0. That is a contradiction. That means the only proposed solution is extraneous. Then you have to give it up. Let me explain why would we have extraneous solution when we solve a rational equation by using this 5-step procedure, because original equation has a domain all real except 0 and 3. There's a restriction on the variable x. The restriction is x cannot be 0, cannot be 3. However, later when we get rid of the denominators, we also get rid of the restriction. What I'm trying to say is this equation has a domain all real. So the domain has changed or expanded. When we change the domain, then there's a possibility we invite in extraneous solutions. That's the reason we have to check if we have any proposed solution when we solve a rational equation. For this case, the only proposed solution is extraneous. So the result or the answer of the problem is no solution. What the solution set is empty. This notation means empty set. All right, those are the 27 problems. Please repeat the video and practice those sample examples. If I were you, I would at least practice 3 times for each problem here. Thank you for watching.